Hey everybody! Today we're going to be reviewing the natural log and also be reviewing the power property from our last lesson. So I'm going to start you with this. What is the value of the ln of e? So what we want to understand is what ln really represents, and ln is log base of e. But just keep in mind that we still have this extra e right here. So what we're really trying to ask ourselves is, what is the logarithm or exponent of base e that gives us e? What is the exponent of base e that gives us e? And I think the answer to that would have to be 1, right? And that's because e to the first gives us e, right? And when we're doing a logarithm problem, we're searching for what the exponent would be, right? So in this case, the answer to this is 1, right? So likewise, the answer to this is 1. Now, ln of e is actually a very important value when you go into pre-calculus, and also many of you will be going into calculus, and it's one of those values that you really want to start committing to memory. So I'm going to put a heart around this. We want to make sure that we understand and recognize that ln of e is equal to 1. All right? There's another special value that we're going to go over. So similarly, what if I wanted to know what the ln of 1 is? Right, and this is a little trickier. So we would want to convert ln to log base e, and then we have that 1 right next door. So this is, again, a little bit trickier. We're trying to look for the exponent of e that gives us 1. What is the exponent of e that gives us 1? And this is a little trickier for people because they forget about the 0 power. So e to the 0 power equals 1. So since, again, when we're doing a logarithm problem, we're searching for the exponent, the answer to this would be 0. And ln of 1 is also another value that's going to show up pretty frequently. And it's best if you just start committing that to memory. Ln of 1 equals 0. So now we're going to incorporate what we learned in the last lesson about the power property. So let's review the power property of logarithms. Okay. And the power property says that if you have a logarithm, let's just say we have the logarithm of base 2 that gives us 3, and let's just say that we had a coefficient of 4 sitting in the front. Right? The power property says that a coefficient of a logarithm can be swooped up, and in this case it will become the exponent of this 3. So what we're really looking at is this. So the power property also works in the reverse way. So let me give you a new example. Let's just say that I wanted you to rewrite the log of, let's just say, x squared. So first thing that I'm trying to force you to recall is that we do not see a base, and when we don't see a base, it is assumed to be 10. And the power property says that this exponent right here really was a coefficient. So another way I can rewrite this problem is 2 times log base 10 of x, right? So it works both ways. So where this property is going to be most useful as far as natural logarithms would be in a situation like this. So let's just say you needed to evaluate, and you had the ln of e cubed. Well, let's go over the common mistake initially. So if you recall from earlier in the lesson, ln of e is one of those special values that I recommended you memorize. Ln of e is equal to 1. The common mistake is that students see a problem like this and they say, oh, okay, so ln of e is 1, and then they do something like 1 cubed, and then they get 1 is the answer, and that's actually incorrect. See, we're not really looking at the ln of e. What we're really looking at is the ln of e cubed, and that's not the ln of e. But what we can do is use the power property. So power property says that when we have an exponent like this, it really was the coefficient. And now that we have the 3 being brought down as a coefficient, we now have the ln of e that we talked about before. ln of e is 1. So the correct answer is actually 3.